Someone posed a question to an AI system that physicists have been quietly losing sleep over for more than 70 years. If the universe is as vast as we know it to be, why has it stayed completely silent? The answer that came back wasn't a monster movie plot about hidden alien overlords secretly steering human history. It was something more genuinely unsettling. Because it's real, seriously discussed territory in philosophy and astrobiology, the possibility that we've been asking the wrong question from the start. Not, why haven't they contacted us? But why do we assume we'd recognize contact if it happened, or that contact is even the right framework to begin with? This is that real conversation, the one serious researchers actually have, without inventing scientists or dressing up speculation as a settled discovery. Let's start with the question itself, because it has a specific, well-documented origin. In the summer of 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory, and in the middle of a conversation that had drifted toward recent UFO reports and the sheer scale of the universe, he reportedly asked a simple question that stopped the table. Where is everybody? Fermi wasn't being flippant. He could run the numbers faster than almost anyone at that table, and the numbers genuinely don't add up comfortably. Our galaxy alone contains somewhere between 100 billion and 400 billion stars. Even conservative estimates suggest a meaningful fraction of those stars host planets, and a meaningful fraction of those planets could theoretically support life. Run the math forward, and the galaxy should, statistically, contain civilizations, some of them potentially millions of years more advanced than we are, given that our galaxy is roughly 10 billion years old, and complex life on Earth only emerged a few 100 million years ago. And yet, after more than 60 years of dedicated listening with increasingly sensitive instruments, we've detected exactly nothing. That gap between what the math predicts and what we've actually observed is what's now called the Fermi paradox, and it remains one of the most genuinely unresolved puzzles in science. When you ask a well-informed AI system, or honestly, when you ask a well-informed astrobiologist to walk through the leading explanations for this silence, you get a range of serious, competing hypotheses, not a single dramatic answer. It's worth walking through them honestly, because the real territory here is stranger and more intellectually interesting than any single manufactured story could be. A decade after Fermi's lunch conversation, astronomer Frank Drake tried to formalize this same intuition into something closer to a testable framework, now known as the Drake equation, multiplying together a chain of factors: the rate of star formation, the fraction of stars with planets, the fraction of those planets capable of supporting life, the fraction where life actually develops, the fraction where that life becomes intelligent, the fraction that develops detectable technology, and the length of time such a civilization would remain detectable before either destroying itself or simply falling silent for other reasons. The equation doesn't spit out a single confident number, since several of its terms remain genuinely unknown even today, but that's precisely its value. It turns a vague hunch that surely something else must be out there into a structured, debatable set of specific assumptions, and it's shaped how the entire scientific conversation around this question has been organized ever since. That search hasn't been purely theoretical either. Since 1960, when Drake himself conducted an early listening project called Project Ozma, aimed at two nearby sun-like stars, the search for extraterrestrial intelligence has scanned an enormous and steadily expanding portion of the sky using increasingly sensitive radio telescopes. Over more than 60 years, using dramatically more capable instruments with each passing decade, this sustained, well-funded, genuinely rigorous search effort has returned the same consistent result: nothing. No confirmed signal, no confirmed technological signature, no confirmed evidence of any kind. That's the honest empirical backdrop against which every explanation below has to be evaluated. And it's worth remembering that the search itself, unlike the manufactured story about secret MIT revelations, is real, ongoing, and conducted entirely in the open, with its methodology and negative results published for anyone to examine. The first, and in many ways most conservative explanation, is the rare earth hypothesis, developed by paleontologist Peter Ward and astronomer Donald Brownlee in a book published in 2000. The core argument is that while simple microbial life might be reasonably common throughout the universe, complex intelligent life may require such an extraordinarily specific and unlikely combination of conditions: the right kind of star, the right orbital position, a large stabilizing moon, a gas giant sweeping up dangerous debris, functioning plate tectonics, that it could be exceedingly rare, possibly even unique to Earth. Under this view, the silence isn't sinister at all. It's simply a probability statement about how astronomically unlikely our specific set of circumstances actually was. The second explanation, the Great Filter, proposed by economist and social scientist Robin Hanson in 1998, suggests that somewhere along the long chain of steps between lifeless chemistry and a civilization capable of spreading across the stars, there exists at least one barrier so difficult to pass that almost nothing gets through it. The genuinely unsettling part isn't the concept itself, it's the uncertainty about where that filter sits relative to us. If it's behind us, some improbable step we've already cleared, that's reassuring. If it's still ahead, something that reliably stops civilizations around our level of technological development, that's a very different, much more urgent kind of silence. A third, considerably stranger idea comes from science fiction rather than a peer-reviewed paper, but it's been taken seriously enough by working physicists and philosophers that it's worth including on its own terms. The dark forest hypothesis, popularized by author Liu Cixin, compares the universe to a dark forest at night, full of hunters, where broadcasting your presence is the single most dangerous thing any civilization could do, since you can never verify a stranger's intentions from light years away, and the safest strategy for everyone, always, is silence. It's genuinely speculative, not established science, but its underlying logic draws on real game theory and real historical patterns of deterrence, which is exactly why it keeps resurfacing in serious discussion rather than getting dismissed outright. And then there's a fourth idea, one that gets less attention in viral content, but is arguably the most philosophically interesting of all, because it doesn't require any of the above to be true. It's sometimes grouped loosely under the term the zoo hypothesis, though the more useful version of this idea isn't really about aliens deliberately hiding from us in a cosmic nature preserve. It's about something more fundamental, whether this is worth sitting with carefully, because it's genuinely one of the more interesting open questions at the intersection of philosophy, cognitive science, and astrobiology, and it doesn't require inventing a secret research team to be worth taking seriously. Consider how contact and communication actually work among species already here on Earth. When a marine biologist studies an octopus, an animal whose nervous system evolved almost entirely independently from our own, with roughly 2/3 of its neurons distributed through its arms, rather than centralized in a single brain, there's a real, ongoing scientific debate about how much of the octopus's actual subjective experience humans can meaningfully access or interpret at all, despite octopuses being demonstrably intelligent, capable of problem-solving, tool use, and individual personality. If understanding a genuinely alien nervous system sharing this exact planet, this exact evolutionary history, and this exact set of physical laws remains this difficult, the question of what communication would even mean with an intelligence that evolved under entirely different physics, on an entirely different timescale, using an entirely different substrate for cognition, becomes a real, serious problem, not a plot device. The same basic humility shows up in real, ongoing research into other forms of animal communication far closer to home than any alien civilization. Researchers studying sperm whale vocalizations through a large, genuinely funded multi-year effort called Project SETI have used machine learning to analyze the clicking patterns whales use to communicate, finding real evidence of combinatorial structure, small variations in click rhythm and pattern that appear to function something like a phonetic alphabet. Even with an animal sharing our planet, our general timescale, and a nervous system built from the same basic biological components as our own, researchers have been careful to describe these findings as evidence of structure rather than confirmed translated language, precisely because bridging the gap between recognizing pattern and confidently interpreting meaning turns out to be extraordinarily difficult, even under nearly ideal conditions. If that gap is this wide for two species that are, cosmically speaking, almost identical twins, sharing a common mammalian ancestor in a shared physical environment, the challenge scales up in ways that are genuinely hard to even properly imagine once you're talking about a civilization that may have evolved on a planet with entirely different chemistry, under an entirely different star, over an entirely different span of time. Philosophers working on the concept of consciousness and mind, including researchers in the growing field, sometimes called xenolinguistics or exobiology adjacent to philosophy of mind, have pointed out that human ideas about what counts as a signal, a message, or an attempt at communication are deeply shaped by human sensory apparatus and human evolutionary history. We search for narrowband radio signals because that's a technology we understand and can produce ourselves, a reasonable starting point for a search, but one that assumes a civilization sophisticated enough to travel or communicate across interstellar distances would still be broadcasting in a format convenient for a civilization at our specific, comparatively early technological stage. It's a bit like assuming a global superpower would still be communicating primarily through smoke signals because that's the most sophisticated method available to the specific tribe currently watching the sky. This connects to a genuinely serious, ongoing conversation in the actual search for extraterrestrial intelligence community about whether our detection methods carry hidden, unexamined assumptions. Researchers involved in real programs like Breakthrough Listen a genuinely funded, real initiative launched in 2015 with significant financial backing, specifically to scan a large number of nearby stars, and the Galactic Center for Artificial Signals have openly discussed the challenge of designing a search that doesn't simply look for a mirror image of our own current technology. If an advanced civilization communicates using something entirely outside our current instrument's capability to detect quantum-level information encoding, manipulation of physical constants we don't yet understand well enough to monitor, or methods that don't map onto anything in our conceptual toolkit at all, the honest answer is that we wouldn't necessarily know we were looking at a signal even if it were directly in front of us. This is where the genuinely interesting and genuinely humbling philosophical question sits, without needing any invented narrative about secret guidance or cosmic parenting to make it compelling. It's the same basic epistemic humility serious philosophers of science apply to a much closer, much more grounded problem. We don't actually know, with full confidence, what the necessary and sufficient conditions for recognizing intelligence even are, beyond the one example we have direct access to, which is ourselves. Every framework we use to search for extraterrestrial intelligence, technological signatures, radio emissions, structured mathematical patterns, is built on the working assumption that intelligence elsewhere would produce detectable evidence, recognizable to minds shaped by a very specific evolutionary and cultural history on one particular planet. That's not an unreasonable starting assumption, since it's the only reference point available. But it's worth being honest that it is an assumption, one that serious researchers in this field openly acknowledge as a real limitation of the search, not a hidden truth. It's worth being equally honest about where this line of thinking shouldn't go, because it's easy for a genuinely interesting philosophical limitation to get pulled into something considerably less careful. The idea that human technological development, including the recent genuinely rapid progress in artificial intelligence, is being secretly steered by unseen advanced intelligences, is a claim of an entirely different character than the modest, well-supported observation that our search methods carry unexamined assumptions. The first is a specific, falsifiable-sounding claim with zero supporting evidence of any kind. The second is a real, humble acknowledgement of the limits of a genuinely difficult scientific search. Serious researchers working on the actual history of human technological development, historians of science studying exactly how innovations like flight, computing, or genetic sequencing actually happened, can trace those developments through ordinary, well-documented human ingenuity, accumulated engineering knowledge, economic incentive, and frankly, a great deal of trial and error and failure along the way. The story of the Wright brothers, or the development of the transistor, or the slow, decades-long accumulation of machine learning research that eventually produced today's AI systems, is a genuinely well-documented human story, driven by identifiable people making identifiable decisions, not a mysterious, external nudge with no discoverable source. The actual history of modern AI is a particularly good example of exactly this kind of ordinary traceable progress, precisely because it's so well documented and so thoroughly unglamorous in its details. The core mathematical ideas behind neural networks were being worked out by researchers as early as the 1950s and 1960s, then largely stalled for decades due to genuinely mundane limitations in available computing power and data, periods historians of the field openly call AI winters. Progress picked back up gradually through the 1980s, 1990s, and 2000s, driven by identifiable incremental advances, better algorithms, dramatically cheaper computing hardware, and the sudden availability of enormous datasets once the internet matured. The specific breakthrough that led to today's large language models built directly on published academic research from the 2010s, with clear, citable papers, named authors, and traceable institutional funding at every step. None of that history has an unexplained gap in it requiring an outside explanation. It's a genuinely long, hard-won story of accumulated human effort, setbacks, and incremental discovery, which is exactly the kind of detail that gets flattened away when a narrative needs a mysterious external force to make the story feel bigger than it actually is. What does connect these two threads, honestly? The real philosophical humility about recognizing non-human intelligence and the real ordinary human history of technological progress is a genuinely worthwhile question about how we'd even evaluate a claim of external influence if one were ever seriously proposed. What would actually count as evidence, distinguishable from the ordinary, messy, well-documented process of human beings solving hard problems over time? That's a real useful question. In the philosophy of science, the same kind of question researchers ask about any extraordinary claim. What specific, falsifiable prediction would this hypothesis make that a more mundane explanation wouldn't? And has anyone actually gone looking for that specific evidence rather than simply noticing that human progress has in fact been accelerating, which it demonstrably has, for entirely explicable reasons rooted in compounding knowledge, population growth, and technological infrastructure building on itself. There's also a real serious body of work considering what actual first contact, if it ever happened, would mean psychologically and socially for humanity, without needing to assume it's already secretly underway. Researchers in fields like the sociology of religion, and scholars specifically studying how human societies have historically responded to profound paradigm shifts, have pointed to historical examples, including the genuinely traumatic and often catastrophic encounters between technologically mismatched human societies throughout colonial history, as a sobering, well-documented reference point for just how badly an extreme power imbalance can go for the less advanced party in any first encounter. This is a real, serious concern raised by real astrobiologists and real ethicists discussing the practical and moral questions around active efforts to broadcast our presence into space, sometimes called METI, or messaging extraterrestrial intelligence, as opposed to the purely passive listening SETI conducts. Physicist Stephen Hawking publicly and repeatedly raised exactly this concern, arguing that broadcasting our location and capabilities to civilizations we know nothing about could be a genuinely risky, potentially irreversible decision. A real documented position taken by a serious scientist, grounded in actual historical pattern matching, not speculation about secret guidance. This debate isn't purely hypothetical either. It's already played out around a real, specific transmission. In 1974, scientists used the Arecibo radio telescope in Puerto Rico to send a deliberately encoded message toward a distant star cluster, a symbolic demonstration of human technological capability, rather than a serious attempt at establishing two-way communication, given that any response, even if one came immediately, would take tens of thousands of years to arrive. That real broadcast has been cited repeatedly in the decades since by scientists on both sides of the METI debate, some arguing it demonstrated a responsible, carefully considered gesture, others, including Hawking, pointing to it as exactly the kind of unilateral decision no single research team should be making on behalf of the entire species without broader global input. That disagreement, playing out among real scientists over a real documented transmission, is a far more grounded and genuinely interesting example of humanity wrestling with the practical stakes of contact than any invented story about a hidden guiding hand. So where does this leave the honest answer to the original question? Not with a single satisfying revelation, and not with any secret confirmation that we're being watched over. It leaves us with several serious, genuinely competing explanations, held by real researchers, none of which cancel each other out entirely, and a humbling, well-supported acknowledgement that our search for answers is built on assumptions we can't fully step outside of, because we only have one example of intelligence to build those assumptions from. That's a genuinely interesting place to land, honestly more interesting than a manufactured story about being secretly nurtured by ancient cosmic guardians, because it's a real, live, unresolved scientific and philosophical question that actual researchers are still working through in published papers, at real conferences, using real instruments pointed at real stars. It's also worth noting that these explanations aren't mutually exclusive, and the researchers who take this question most seriously tend to be comfortable holding several of them at once rather than insisting on a single tidy answer. It's entirely possible that complex life really is rare, exactly as the rare Earth hypothesis suggests, and that among the small number of civilizations that do emerge, some additional filter, whether self-destruction, environmental collapse, or simply the sheer, staggering scale of interstellar distance and time, further reduces how many ever become detectable to a species like ours, watching from one small, quiet corner of one ordinary galaxy. The universe doesn't owe humanity a single clean explanation wrapped up with a satisfying bow, and pretending otherwise, whether through a fabricated research team or an unfounded claim about secret guidance, does a disservice to how genuinely strange and genuinely open this question actually is. If the rare Earth hypothesis is correct, the silence tells us we may be genuinely, remarkably alone, which should make us treasure and protect the one confirmed example of complex life in the universe, rather than treating our own survival carelessly. If the great filter lies ahead of us rather than behind, the silence becomes a kind of quiet warning about the fragility of technological civilizations, worth taking seriously regardless of whether any alien intelligence exists at all. And if the deepest problem is really about the limits of what human minds can recognize as intelligence in the first place, then the most useful thing that question does isn't hand us an answer about aliens. It teaches us something genuinely valuable about the limits of our own perspective, a lesson worth taking seriously on its own terms, whether or not the universe ever answers back. If you're drawn to the kind of story that stays honest about genuine scientific uncertainty instead of manufacturing a tidy, secretly orchestrated answer, subscribe, because the real questions here are strange enough on their own, and they're nowhere near settled.